Now we are going to see about the next experiment. Design and testing of active filters, low pass filter, high pass filter and high pass filter. And here we are going to design these three filter and obtain the frequency response. According to the situation, low pass filter is the it allows the low frequency component from 0 to the FH, and after FH it does not allow the frequency to pass over. Similarly, high pass filter will allow the frequency from 0 to FL, that is, it will not allow the low frequency from 0 to FL, and it will allow the frequency greater than that of the FL. This is called as low pass filter. Then for band pass filter, we have to band frequency to range of frequency FH and FL. The frequency range between these FH to FL is allowed to be passed, and based on the two types, narrow band pass or wide band pass filter. If Q value is less than 1, less than 10, it will be taken as a wide band pass filter. If it is greater than 10, it will be a narrow band pass filter. The design procedure for low pass filter is given here. We are assuming the high cutoff frequency is 4 kilo ohm, and using this formula with C equal to 0.01, we have calculated the value of R, and we know, assuming the gain is equal to 2 and R1 equal to 10 kilo ohm, the RF is calculated as 10 kilo ohm. Similarly, for high band pass filter, the RL value is taken as 4 kilo ohm and RC equal to 0.0 microfarad, and R value is calculated with taking A equal to 2 and R1 equal to 10, RF value is 10 kilo ohm. Next, for band pass filter, we use two frequency, high frequency and low frequency. Therefore, we are going to design these two components. So for that, C equal to 0.01 microfarad and R dash is equal to 3.97 microfarad. By taking R is equal to RH is equal to 4 kilohertz, with A equal to 2 and R1 is equal to 5.6. RF is calculated as a 5.6 kilo ohm. Similarly, for high pass filter, F1 is taken, F1 is 400 and C is equal to 0.07, therefore R equal to 39.7 kilo ohm. With A equal to 2 and R1 equal to 5.6, the RF can be calculated as 5.6 kilo ohm. Using this design, we have to draw a circuit diagram for the low pass filter, high pass filter as well as band pass filter. We are going to take the AC and response, that is the frequency response of this filter. We are going to plot the magnitude as well as phase response. This is the circuit diagram of active high pass filter. This is the circuit diagram of active high pass filter, where R and C is connected in the negative inverting terminal in the series combination, and R2 is a feedback resistance. We are giving a 10 volt frequency source here, and now we are going to take the output. You can see the frequency response in this graph. If we simulate, we can see the frequency response magnitude as well as the phase angle of the output. Here we taken as a fourth terminal V4. The magnitude is green and the corresponding phase is also green. This is the magnitude curve and this is the phasor curve. Magnitude is a solid curve and phasor is a dotted line curve. This graph is drawn in logarithmic scale. We can change this to the dB scale also. Okay, now we can draw this in the dB scale also. This is the diagram for the active high pass filter and this is the simulation. So, we can see the real-time simulation output. This is the magnitude curve and this is the phasor curve. Similarly, we can see the output for active high pass filter. We can also see the DC response, that is the transient characteristics. We can also see the response of voltage, input voltage and output voltage response. We can see the various response using these tools, and now we can see the frequency response AC sweep of this high pass filter. Okay, next we are going to see the this frequency response of the low pass filter. This is the circuit diagram of active low pass filter, and this active low pass filter consists of RC in the feedback network connected in parallel combination, but in high pass filter RC is connected in the input negative terminal of the op-amp in series manner. This is the difference between these two. In the op-amp, positive terminal is grounded and the minus VCC is given around 5 volt, and plus VCC is given around plus 5 volt, and minus VCC is given around minus 4. We can give the voltage up to 14 volt. Now we have to just give a sine wave with some voltage, so that we can vary the frequency and obtain the magnitude as well as phase value, in the Bode plot. For that we have to just click the AC sweep, and we can get the AC sweep characteristics in the graph. See, this is the graph. The solid line is the magnitude and the dotted line is the phase which we obtained in the active low pass filter. If you want to obtain the voltage response, we can move for the interactive character, which will provide the voltage response between the input as well as output. But we are going to study only the frequency response, so that we can take it as an AC sweep and we can see the magnitude as well as phase response. Here we calculate in the dB. We can change the value either in dB or logarithmic scale. Next we are going to see about the band pass filter. This is the active band pass filter. In this active band pass filter, we are going to see this is the active band pass filter circuit diagram. This active band pass filter circuit diagram, we are going to see that the input negative inverting terminal consists of RC combination and the feedback terminal consists of RC combination. This is the band pass filter. This consists of high pass filter as well as low pass filter. Therefore, in the design we taken these parameter, and we can substitute the design parameter values and or else this value, so that we get the output. This is the input voltage is represented by this light blue, and the output voltage is represented by the dark blue value. Here we are going to study the frequency response, so that AC sweep, we have to choose the AC sweep and click run button. This shows the magnitude value as a solid line and the phase value as the dotted lines. This is the output for active band pass filter. Thus we have seen the output for the active band pass filter, low pass filter, high pass filter, magnitude response. We can also see the input output characteristics by selecting this value as a active, and if we choose the AC sweep, then we will get the magnitude value. Similarly, magnitude can be plotted in either logarithmic value or in the dB value in this simulation. Thank you.